Central bank can control the money supply. So we're going to talk about first the tools of the central bank. The central bank is the Federal Reserve, and if the economy is lagging, then they can pursue an expansionary policy, and that expansionary policy is to increase the money supply. Okay, there are four ways that they can increase the money supply. Open market operations, which means in this case it would be buying bonds because they want to increase the money supply. If they buy bonds, then they put cash out in the economy to private and to individuals and banks that own bonds. That own bonds. They buy the bonds from those people. When they do that, they put cash into the economy. Okay, so that they can increase the money supply by buying bonds. That's an open market operation. They can decrease the reserve requirement, how much they require of the banks to keep up demand upon us to keep in the bank in their reserves. They can decrease the discount rate. That's the rate they directly charge banks to borrow money so that they can keep up to their required reserve. And they can discount the federal funds rate, which is kind of influenced by the discount rate. The federal funds rate is the rate that banks charge each other to borrow in order to keep required reserve. And the Federal Reserve doesn't directly control this, but their policy influences the federal funds rate. What they do is to try to influence the federal funds rate, and it's the main rate that impacts the money supply, the federal funds rate. So open market operation. The Fed buys U.S. bonds in the open market, putting more money in the hands of private citizens and banks. Okay, so we have some related graphs to that. If the government sells bonds, if we graph that, okay.
They buy bonds or sell bonds?
I'm going to do both. I'm going to do if the open market operations. Now we're going to do if they sell bonds, that's going to decrease the money supply. That's to stop inflation. So the government sells bonds. So we're going to draw the money market graph. So we have quantity of money here. Here we have the nominal interest rate. This is the money market, not the loanable funds market. Nominal interest rate, and then the money supply. We know it's perfectly inelastic. It doesn't change with interest rate. Just the Fed controls it, changes that by buying and selling bonds. And then our money demand is a downward sloping curve. There's money demand. This is this curve, we label it money supply 1. Okay, so if so the money market, if they sell bonds, that's going to mean that they accept money from private individuals and banks and give them a bond, so that takes money out of the economy. So that's going to decrease the money supply. So we would be at M2, and that's money supply 2, right? That's a decrease. And so our interest rate goes from R1. It increases the interest rate. There's less money, so there's money's more expensive. So the interest rate goes up. This is the interest rate effect. Okay, so that's a graph of the government selling bonds. Okay, so what happens? The chain of events with this is the government sells bonds. When the government sells bonds, the money supply decreases. When the money supply decreases, as you can see from the graph, the interest rate, nominal interest rate, increases. If the interest rate increases, what's going to happen? What's going to be affected? Interest rates go up. What happens in the economy? Investment goes down. You could also say that consumption, because a lot of consumption is credit-based. People buy things with credit cards, which have interest rates. Okay, so consumption would also be acceptable, but most commonly we would say that, the interest rates investment would decrease. If investment is one of the components of aggregate demand, so aggregate demand would decrease, and then that's going to decrease real GDP. That's a contractionary policy. They're trying to slow inflation when they do this, when they sell bonds. All right, that's currently what they're starting to do right now. The Fed has decided to raise interest rates because the economy was hurting. We had that the Great Recession of 2008. It took us a long time to recover. Now the economy's healthy, and we're starting to have inflation, and so their interest rates for a long time were close to zero. But now they're starting to raise the rates so we don't have inflation that gets out of control. All right, so that's one open market operation. Let's look at the other one. Is the one we were talking about. It applies to what we started talking about today, and that was we want to expand the economy. So that would be graphed as the government buys bonds. Okay. Again, we're going to graph the money market. And so we have the nominal interest rate on one axis, quantity of money on the other, and we start out with M1. That's the money supply 1 curve.
Money demand, that can be a straight line or curve, right?
Yeah, we can draw it like this. Money demand. Okay, and we have R1, right? And they buy the bonds. That puts more money into the money supply, so that shifts out. So we have money supply 2, and so this is going to be M2, and that brings the interest rate down to R sub 2, right? And that's expansionary, right? They're trying to increase aggregate demand. So the chain of events, the government buys bonds. Okay, that's going to increase the money supply, right? And then when the money supply goes up, interest rates go down. When interest rates go down, investment increases. When investment increases, aggregate demand goes up. When aggregate demand goes up, real GDP goes up, right? So that's government buying bonds. Everybody have that graph? Okay. All right, now something else I want to note. We've talked about this, but let's review it. As interest rate goes up, what happens to the price of bonds? Price of bonds does what? Interest rate goes up, price of bonds does what? Goes down. They're inverse. Price of bonds goes down. As R goes down, price of bonds goes up. All right? Just make sure you know that's an inverse relationship. Okay, any questions? Okay. So, the second tool, decrease the reserve requirement. Enables the banks to loan out more money because they have less required reserves. And so it's another way to increase the money supply. Decrease the discount rate. This is the rate the Fed will charge member banks for loans to make up shortages of the reserve requirement. Okay, that's the discount rate, the rate the Fed charges banks. Then the federal funds rate. This is influenced by the Fed decreasing the discount rate, and that's the interest rate on short-term loans between banks. Okay, this is the target rate of the Fed when conducting open market operations. All right, if they want to decrease interest rates through the federal funds rate, then they're going to sell bonds, and that's going to no, they're going to, let's see. So they would, to decrease interest rates, they would sell bonds, and that would, no, they would buy bonds. Okay, they want to buy bonds. That's going to decrease the interest rate. They would buy bonds. All right, any questions? Okay. Note, the Federal Reserve has $1 trillion in its basement in case of a run on banks. What do I mean by a run on banks? And when did this happen? Huh? Sort of.
The Great Depression.
Yeah, the Great Depression. A run on banks is everybody's panicked about money, and they don't trust the bank, so they go to the bank and they want all their money. All the money they have in the bank, they want to cash it out. They want to have it in hand, right? The banks naturally don't have all that money. They have just required 10% of what everybody has given them, or whatever the reserve requirement is, but they don't have all that money. So, that causes a crisis. Who's seen It's a Wonderful Life? Okay, that's a run on a bank. It's about a run on a bank, okay? So, this is not money until it is put into circulation. Okay, so they do have cash in reserve in case there's a run on banks. All right, so an expansionary policy, we've got decrease the reserve requirement, decrease the discount rate, buy bonds. Okay, buying bonds is going to affect the federal funds rate. Okay, so the money supply goes up, interest rate goes down, investment goes up, aggregate demand goes up, real GDP goes up. That's the expansionary policy. All right, any questions? So, at a free response on the AP macro exam, they're going to ask probably in the large question sometime a question about open market operations. They'll probably have you graph it. The graphs I just did, okay? Those will probably be a question, some form or other, on the free response. And, they may not tell you expansionary, contractionary. They'll give you a situation. There's high inflation. What's the federal government going to do? What policy would they pursue if there was high inflation? What's that? Contractionary, yeah, they'd sell bonds, right? And if the economy's in recession, they want to buy bonds, right? Expand. All right, now we're going to get into the quantity theory of money. Okay, the quantity theory of money is a theory asserting that the quantity of money available determines the price level, and that the growth rate in the quantity of money available determines inflation rate. Okay, there's an equation that we use with the quantity theory of money, the quantity equation. It's MV equals PY. M is the quantity of money. B is the rate, okay, of money, the rate of the money, and PY is price times output. When we know price times output is nominal GDP. Okay. So let's talk more about V, the velocity of money. It's the rate at which money changes hands, wallet to wallet. So how fast are people spending money? That's the velocity of money. Okay. If times are good, the velocity of money is probably higher than in a recessionary time. People hold on to their money more in a recession. Okay, here's an example. Let's say the economy only produces pizzas, right? They produce 100 pizzas a year at $10 each. The quantity of money in the economy is $50. So we want to know the velocity of the money. That's the unknown. We plug in what we know. We plug in 50 for M. V is the unknown. $10 is the price and of the pizzas, and 100 is the output. Okay? So we solve for V, and you can see the velocity of money, $20 per year. All right? The velocity of money is $20 per year. So, that's how quickly the money is changing hands. All right? Any questions on that equation? Just remember, MV equals PY and plug in and solve. Velocity is usually stable. Okay? Velocity of money is usually stable. Okay? When we increase the money supply, okay, or increase in the money supply is typically as a result of increasing prices, increased output, or decreased velocity. Right? Those are the things that would, and that makes sense if you think of the equation. Right? For M to go up, if we have the equation MV equals PY, right? To cause M to go up, right? Then if we're assuming PY stays the same, if velocity goes down, M would go up, right? That's consistent with that equation. Or if we had either of these, if P goes up or Y goes up, to balance the equation, if velocity stays the same, M has to go up. All right, so that's where you get, if they ask you a question about what happens to M if P, Y, or V changes, just think of the equation and what would cause M to go up in that equation. Okay, so we have, we're going to take a look at an illustration on page 654 of Mankiw. Describes what changes price and inflation from the quantity theory of money. So let me put that graph up here. So what we have here is the nominal GDP and the quantity of money. You can see that they went hand in hand from the 60 to 1990. They were pretty much identical. Okay. Then M2, which is the larger measure of the money supply, right? Then M2 now in the 90s, and now there's a gap. The rate that they're rising is now the same, but the nominal GDP is greater than the money supply. The velocity, you can see, has remained stable. Right? The nominal GDP and the money supply have grown dramatically over this time. Okay, so there's been a lot of growth. The money supply has also grown. Velocity of money has stayed the same. Okay. Any questions? Okay. So we said P times Y is GDP, nominal GDP. So the money times velocity also equals GDP. To increase GDP, we have to increase the money supply because we're assuming velocity is going to just stay the same as just shown you. Okay, to increase GDP, there has to be some increase in the money supply. There has to, and that means some inflation. And the government we've talked about before. What causes inflation is the government printing more money, right? So it's healthy for there to be a little bit of inflation in the economy. Around 2% is what the Federal Reserve, that's their goal, to have inflation be around 2%. Okay, so that's going to they're going to have to increase the money supply for there to be some growth. So now we're going to talk about present value. The present value is the amount of money today that would be needed to produce, using prevailing interest rates, a given future value of money. All right? So how much money today do we need to produce a future value of money? So if we take future value, okay, you're going to, if you have $100 and the interest rate is 5%, I would multiply so in 1 year that money, what would I multiply $100 by? Yeah, 1.05. 100% plus 5 more percent. 1.05. If we made that a percent, it'd be 105%, right? So we take 100 times 1.05, and we'd have $105 in the future, right? That's what we're doing here. 1 plus R, okay, the rate is expressed as a decimal when we do this. We take that, so that'd be after 1 year. After 2 years, okay, we would have to take it times 1 plus the interest rate squared, or times itself twice, right? If after 3 years we take that amount and it's times the interest rate 3 times. So that continues on, so we end up with the equation future value equals 1 plus the interest rate as a decimal. The exponent on that quantity is the number of years that you're compounding the interest, okay, times present value. So that's the key equation. You need to know future value equals that. Now you may have to solve for present value. Then it's just the future value divided by 1 plus R to the n. All right? So let's find the future value of $100 in 10 years with an interest rate of 5%. Okay, so my equation, if we plug in, it's be future value equals what? What would it be? Yeah? 100 times 1.05 to the 10th. Calculate that. What would $100 in the future be with an interest rate of 5%? Ian?
I got
162.8. Does someone concur with that? Someone else calculate it. What, you get that? So 162.8 you say? Let's just call it $163. Okay? $163. So yeah. So if you have $100 today in 10 years, that'll be worth $163 if you put it in the bank and it earns 5% interest. Everybody got it? All right. So then, like I said, you can also solve for present value, the future value, right? If you want to know what $10,000 in 10 years is worth in today's money, you just reverse the equation, okay? So our example, is it better to have, this is a type of question you might have to answer. Is it better to have $100 today or $200 in 10 years if the interest rate is 5%? How would I figure this out? What would I do? Yeah?
You'd have to calculate the future value of the $100 and then calculate the present value of the 2.
Well, one or the other. You don't have to do both. Let's do it. Let's find the present value of $200 in the future, just to simply apply this equation. Okay, so we take we would have present value equals 200 divided by 1.05 to the 10th. Okay, so what is the present value of $200 in 10 years? Somebody calculate that. How much?
325.
No, it's going to be less than 200. What, Ian? What'd you get? 123? It's worth 123 today. All right? So is it better to have $100 today or $200 in 10 years?
$200.
Yeah, $200 in 10 years. It's worth more. Okay. Everybody get it? Okay. All right. Okay. All right. So then, that's it.